Our lesson today is going to be about counting. During this lesson, we are going to discuss the notation and factorial, and then we are going to discuss permutation and arrangement without repetition. In order to start with this lesson first, we are going to discuss n factorial. By n factorial, we mean the product of the numbers, of the natural numbers from n to 1. For example, if I have 5 factorial, 5 factorial is 5 times 4 times 3 times 2 times 1. So it is the product from 5 to 1 of the positive integers. It is read as 5 factorial. The value of 0 factorial is 1 by convention. If I want to find or evaluate 8 factorial, this means that 8 times 7 times 6 till I reach 1, the product from 8 to 1, which is 40,320. Let's take another example. 4 factorial. Pause the video and think about it a little bit. 4 factorial is equal to 3 times 2 times 1. Let's take another example. What do you think about 9 factorial? Pause the video. 9 times 8 times 7 till we reach 1. The product from 9 to 1. Now we are going to discuss the following notation, which is n plus 1 all of it factorial. This is a property of factorial where we can simplify the n plus 1 factorial into n plus 1 times n factorial. How can we apply this? We can apply this by saying 8 factorial is equal to 8 times 7 times 6 factorial. Or 5 factorial is equal to 5 times 4 factorial. So I can stop wherever I want. Or I can say 5 factorial is equal to 5 times 4 times 3 times 2 factorial. So I will stop according to the question or to the need of the question. As you can see, we can see this example, 8 factorial over 6 factorial. In order to solve this, first I'm going to write out each factorial and simplify it. 8 factorial is 8 to 1 and 6 factorial is the product from 6 to 1. Then I will simplify to get 8 times 7, which is 56. Can I use the formula we just had? Yes, we can say that 8 factorial is equal to 8 times 7 times 6 factorial, and I will stop on 6 factorial because I need it. Then I will simplify the 6 factorial with the 6 factorial to get 8 times 7, which is 56. Another example. If I have 10 factorial over 9 minus 2, all of it factorial. Step number 1, subtract. 9 minus 2 factorial is equal to 7 factorial. So I will first say, what is 10 factorial? It is the product from 1 to 10. What is 7 factorial? It is the product from 1 to 7. Then I will simplify to get 10 times 9 times 8, which is 720. Can I use the property we just had? Yes. If I have 10 factorial, then I will stop at 7 factorial. 10 times 9 times 8 times 7 factorial. Then I will simplify the 7 factorial to get 10 times 9 times 8, which is 720. So now we are able to use the factorial, or we know how to use the factorial. Step number 1, we are going to write the factorial of the number. Step number 2, we can simplify if there is a need. Step number 3 is to find the product. Now, let's see the following way in order to solve using the calculator. If I want to solve the n factorial using the calculator, I will have two notations on my scientific calculator. I might either have x factorial or n factorial on the scientific calculator. Let's see the following example. If I want to arrange 3 bottles of water on shelf, the bottles are labeled A, B, and C. So I have 3 bottles of water. I want to arrange them on my shelf. How many ways can we arrange these water bottles on a shelf? Pause the video and think about it and tell me how many you are going to find. In order to solve this one, we're going to find 6 different possibilities. Think about it as if you have 3 chairs. So if one of the bottles is on the first chair, then I will have only 2 possibilities for the second chair, and at the end I will have only 1 possibility. So if I chose A, remaining is B and C, then remaining is C. The same way we are going to proceed with the 6 different possibilities. So, permutation is an arrangement of things in a certain order, if no bottle can be used more than once. So, the condition is that I have no repetition. When I chose to arrange the bottles, first I got 3 choices at the beginning, then I have only 2 choices at the second position, and eventually I have 1 choice in the third position. Can we see this product as 3 times 2 times 1? It reminds us with 3 factorial. So we can have the following rule. If I want to find the permutation or the arrangement of n elements of the set E of n elements, this means that I can write Pn, which is equal to n factorial. If I want to arrange 5 bottles on a shelf, then it is 5 factorial. If I want to arrange 9 bottles on a shelf and all I have is 9 bottles, so it is 9 factorial, and so on. But what does this mean? If I want to find permutation or an arrangement of a set of 5 elements, however, I only have the possibility of using 3 of these elements. How can I solve such a thing using arrangement? In order to solve such a question, we have the following problem. We know that water have many minerals. Of these are calcium, magnesium, sodium, potassium, and bicarbonate. On a label of a certain water bottle, I only have the choice of using 3 of these minerals on the label. So, can you think with me and tell me how many different possibilities do I have in order to make this label? Pause the video and think about it a little bit. We can see that in order to solve such a question, first I must see that I have 3 choices or 3 places. So, I have the first place, I may choose either potassium, calcium, magnesium, sodium, or bicarbonate. If I choose one of them, then in my second position, I will only have 4 different minerals, which are calcium, magnesium, sodium, and bicarbonate. If I choose one of them randomly, for example, magnesium, so in the third position, I will have only calcium, sodium, and bicarbonate. How can I write this using factorials? Since I know and this one is 5 times 4 times 3, we are going to write this by using factorial. So we can write this as 5 times 4 times 3 times 2 times 1 over 2 times 1. This reminds us with n factorial. So the rule says if I want to arrange elements of a set and I have only certain options or certain items to use, so n is considered to be the number of items in the set, r is considered to be the items at a time that I want to arrange, and I'm going to follow the rule npr is equal to n factorial over n minus r factorial using my calculator. Or I can arrange the n elements of the set in r positions if I have r positions. So let's apply this on the question we have. The arrangement without repetition for such a question is npr equal to 5 factorial over 5 minus 3 factorial. How did we do that? Let's see. Step number 1 is that I have n items, which are the 5 minerals. Step number 2, I have items at a time, which are 3 minerals at a time that I can use. Now can we apply the rule? 5 factorial over 5 minus 3, all of it factorial. 5 factorial is the product of the numbers from 5 to 1, but I can still use my rule and say it's 5 times 4 times 3 times 2 factorial. Simplifying 2 factorial in the numerator with the 2 factorial in the denominator, this will yield 60. Now, after introducing factorial and having a little bit conversion, and then we are going to to discuss permutation and arrangement without repetition. In order to start with this lesson,